This is a big fabrication episode, just like last time. I continue with the frame, add the Bogie support bars, fabricate the buffers, weld the Kingpin, the wheel sets, and clean up everything. But also start putting the first Bogie together and realize all the things that I've overlooked in the CAD design. Enjoy! Welcome to a new episode where I continue with the wagon. And well, I already started welding when I realized that I haven't, recorded an intro, but I still have a lot of parts which haven't arrived, and I'm still missing the box sections because the metal shop where I usually go to buy supplies is out of that particular part, and they said that or the particular section, and they said that they want to wait for a few more orders so they can send a truck with a full of truck full of supplies, which means that I might have to wait for a couple of more weeks. But anyway, I have those sort of cross members, those braces that I want to weld in, and I also want to reinforce the couplers because I haven't welded through the seams, and I was grinding it down in the last video. I just realized that I don't think that I have enough penetration. Not that it's going to be a problem. I mean, probably still going to be plenty strong for what I'm going to use, but I'm just going to do a little bit more weld around that. So I think it's going to be a fairly short session today, but I want to get it done so I have less parts lying around, more parts, welded together, so I have a little bit more space in the workshop. So I was a little bit concerned doing this because last time I did exactly the same for the loco. Then as I started welding these seams, I guess because of the heat, this U channel started to expand and then it popped out on one side. So I had to grind down all the welds and everything. So this time I wanted to make sure that I do tacks on each side, and I started to do welding here and on the opposite side and then go to the next one. So basically just try to introduce as little heat as possible. And then, I have like 3 big seams here, one on the corner, so I don't think this is going to go anywhere. And with this, the main chassis is done. Actually, I think I'm going to flip this around and probably fill up this weld from the other side as well. And then this should be ready. Okay, to be honest, I think that's going to be it for today. And I just got some beeps. I got this air quality sensor from Banggood, and yeah, it starts beeping because the PM 2.5, I think that was the one. So that's going to amber. So it's probably all the fumes and everything. Interestingly, the CO2 doesn't really go up. I mean, even though I'm, welding with CO2, maybe it's so low that everything, all the CO2 is on the floor. I'm not really sure, but yeah, the particulate matters definitely go up, and I think previously it was even higher. So some of the PM 1.0 was also in the orange, but it's still not red. I mean, granted, I was welding for probably half an hour, so yeah, maybe it's not that bad. But anyway, that's how it looks now. So I wanted to weld these seams on the top as well. Oh, something is wrong. Yeah, now all of them are in. Yeah, as I move around and stir up the air, I think it goes up and down. Okay, back to the subject. I'm not really sure what I've done here. What's this? Come on. And then, yeah, these are the couplers. I think it's still hot. Yeah, so anyway, I need to grind this down. I was so stupid because, as I said, usually when I have these cutouts and the tab, I leave the tabs below the surface. So this is like 5 mil and the tab would be only 3 mil deep. So there is space for me to weld here, but I didn't do it here. So basically I just had to butt weld all these fingers, which is not ideal. But yeah, so I grind them down, and whenever I could see a lines where there was no, the two weren't welded together, I added some more welds, and that's it. Yeah. So for next, I want to make these buffers, and to be honest, these are only cosmetical because I end up using a fairly long drawbar, so the buffers never really touch. But it's a nice touch. It looks good, and in fact, it's functional. And instead of guessing, I think I'm just going to take this off. I try to take this off, and yeah, we'll just take it inside and replicate all these, and then just make 4 more of these. So that's it. So it's basically 2 parts. This is a plate with a tube on it, and that's a smaller tube with a round piece. And there is a spring here, and this one goes through a hole in the middle, and that gives this springy. And on the other side there is a nylon washer. Sorry, a nylon nut. What is it? Self-locking nut. Locking nut. That's it. Very simple. And this one was made when I was hand cutting it, so it's really crooked. So now I'm just going to use the metal hose saw, and it's going to be much nicer. So it's 3 centimeters. This one, that's about 3 as well. So I think I'm going to cut 3 centimeters each. so the way I created this conical surface is I had these blanks, laser cut, and I'm actually going to use this bolt to press it against in a vise. Actually, I think I can use, so this is an M8, I can use a smaller one. Let me just get a smaller. Yeah, that should do it. So let's do it. Of course, the trick is that you try to get everything centered, which it doesn't always work. But this is roughly centered. And a bolt, sorry, a screw goes into the center. Okay. Okay, that should do it. Yeah. That looks good. And by the way, this is the pipe that I cut for the, so that's going to go in here. No, that goes onto the, that's the wider one. So the smaller pipe goes in here. And that's it, it's bent. As you can see, it's off center, but that's how much I can do with eyeballing it. Yep. Off center. Oh, the vise is pushing off center. Yeah. Okay. Yeah. That one is perfect. Okay, so a friend of mine has a friend who has retired, like 80-something-year-old, but still goes back to the shop to do some machining. And he actually machined these, I don't know, nylon spacers for me. So that's going to sit on the Bogie. So that's going to slide on the brace, which is on the underside of here. And he also machined these UCT blocks, so cut the tops off and put a groove in there. So that's how they originally look like. So you just cut this off, and in the local design I had 3 slots milled into here, just small pockets where the springs sit, but that design is going to be different. This guy is going to sit in here, oh, the other way around, so like so. And I also have this plate, so this goes on here, and these two are 5 mil, and the slot here is 11, so it has a little bit of play. And then this plate is going to ride on this groove which got milled here. You can see this has a little bit of curve, so as it sort of like pivots over, there is always a contact point. I also added this to make sure it doesn't ride off. So that's going to be in here. Of course, the other one is going to be here, and that's going to be pushed down by a big spring here. So yeah, that's the design. So the only thing which is left is, well, of course that's not the only thing which is left. I have these 2 bolts, and I'm not pretty sure whether I should use this shorter one or a smaller one. So these are M10s, and they will be welded on from here. welded on from the underside. So that's going to be the Kingpin. And I'm just not sure which length I should be using. So I'm just going to test it out now. Okay, so that's the shorter one. I need to move this. Okay. And actually we are looking at how much this comes through here. Not enough. Let's check the longer one. So this looks like it just flush here. So I think I'm going to choose this one because I have a little bit more space to put this nut on. And this has a nylon nut. So I just going to make this to loose fit, and the hole for this M10 nut is 10.5 mil, and that allows the Bogie to pivot. Sorry, I mean like pivot this way, and then it has the two nylon washers to rest on. So this is just make sure it doesn't drop off, and of course it picks up lateral forces. Okay, so it's the longer one. By the way, I decided to use the main frame as a welding table. So the earth is clamped here. So especially these small parts, I think I'm just going to weld them here. So I need to tack this M8 on relatively vertical, and then the small pipe gets welded on. And oh, I need the other parts as well. And these are the back of the buffers, and that's where the big pipe goes on. And that's the buffer. That's all. Very simple. So let's open the gas and turn on the welder. Yeah, I would say relatively perpendicular, and doesn't come off. Of course, this is galvanized, so yeah, it just fumes. I mean, the bolt is galvanized. Yeah, that ended up a little bit off center, but you're not going to notice it. I was spinning it and sort of like did this whoops circular weld. Unnecessarily strong, but yeah, as you see, it's a little bit shit. So this is a little bit off center, but yeah, it's not going to matter. It's not going to not going to win any welding contest, but that should do. Oh. I put way too big beads here, so this small part doesn't always, well, here it sits flush. On this one, it doesn't really do that. Well, this ended up being really crooked. I mean, I can always redo these if I want to. I will see how they look on the wagon itself, because you can sort of like turn it in a way that it's not going to be noticeable. It was the same with the local as well, so I'm not too worried about this. Okay, I did a few spots here only, but again, it's not going anywhere. I think this one is going to be a little bit more tricky, because so you will see more of these than the other one. So this should be, I think I'm going to reduce the cart. So it goes a little bit slower. Ow. I have way too much color on these welds and I don't really know what that means. Maybe I'm going too slow or maybe I'm going too fast. Okay, that's done. Not nice, but done. Okay. think it's time to also weld these wheel sets together. And the way I had these made is, oops. So the axle has this small recess, so it is easy to just push the wheels against them and then weld. And it's fairly good tolerance here. So there is no play. There's virtually no play. So I think I'm just going to maybe through the holes here. And I mean, that's already perpendicular. And I can just flip this around. And then previously I had this template made as well. So you can put here, and that keeps the wheels apart. But now I don't need, actually I think this is 1 mil less. So I have a little bit more play. There is enough threads on these wheels that it doesn't matter. But my loco has the same wheel sets and they are running fine. So I'm not going to bother too much. So I think I'm just going to weld them. As I said, put the axle through here. And it's going to be fairly perpendicular anyway. And I just flip it around. Yeah. This doesn't move. Whoa. Ugh. I'm not even going to weld from the outside. So, one set off. Ugh. What do you call these? Drum bells? Yeah. Oh! Oops! It basically just broke apart. Fuck. I think this is way too much activator. I can wash this off from my hand with soapy water. By the way, probably I should have cleaned the metal surfaces, but it's a little bit too late for that. Setting already, it's getting a little bit harder to spread. Yeah, I probably need to clean this one up much better, because then if I get too much stuff on it, then I won't be able to get the screw heads flush. Yeah. It is already setting. It gets really hot. I think the fact that it's fairly cold here is not helping either. Okay. That's useless. I think I just managed to get the last pieces on. I hope some of it is going to stick. We'll see in half an hour. And yeah, it comes off with hot water. So that's gone. Okay, so let me try to dry fit the first bogie, and I know it's not going to be complete because I don't have the springs yet, but I want to see how that looks, and yeah, just get a general feel of what I need, especially in terms of springs and everything. So yeah, but I have everything now, so we should be ready. Okay, so I was just about to drill into these, and I realized how much smaller these are than 6 mil. And again, this is 5 mil plates, and here the bolt size is good, but here it is too tight. So I have to go back and check my drawings, because I think probably what I did here is I was planning on tapping these. So probably I need to tap this M6, and then I can just use a very short bolt just to go through, and so I wouldn't need a nut on the other side, and I can use the hex head, which has a smaller head, and that's going to clear the bearing blocks. So probably that was the idea behind this. And this is probably specified as 5.8 or something, which is the hole size for an M6 tap. But I need to check, so probably this assembly gets a little bit delayed now. Okay, so this is the basic design, and that's where I think I'm going to end this video because I need to get some other supplies. But you can see how these bearing blocks ride in this basically, well, they have this channel here, and this channel is, I said 11, no, it's actually 12 mil. So the two 5 mil plates give enough room for it to move up and down. So the 5 mil, this one and this one, creates that basically channel. And then this V-shape member, that's going to push it down with a spring that I still need to buy here. So there's going to be one big spring here, which is going to push it down, and that would allow the, you know, this frame to sink under load. And obviously that spring is going to be in compression. And if I can just move this a little bit so you can see how this is all going to move up and down. And of course this allows sort of like this tilting motion as well. And yeah, so this thing is just going to ride on. So I think I mentioned this previously. I don't know how much friction there is going to be between this plate and that plate, and whether this is going to try to swivel out, how much the, you know, spring is going to push it down in the middle. But I guess I will just have to see how that works out. The one thing I also realized, which I didn't realize in the drawings, is that this nylon basically washer thing, it's on an M6 bolt, which you can see here. So I don't know if this is going to be in a way, if I have a big enough spring, that spring should be outside this M6 bolt, but I might have to change this to a set screw. So it can be, well, I can't change it to a set screw because otherwise nothing is going to hold it. So I don't know how this is going to work out with the spring. This M6 could be in a way, which is not good. I only realized it now. And as I said previously, these need to be changed to a different type of, not a hex head, but probably like an Allen head. And I also realized that the threads are made at an angle. Obviously I couldn't hold the screwdriver perpendicular to the plate. So these are a little bit binding because that's an exact 6 mil hole here. So this is going at an angle. Well, I will have to see maybe I need to ream this hole just a little bit bigger, just to make sure that I can screw it in. But yeah, otherwise I think it's looking good. So I think I'm going to end this video. In the next one, we will pick up from here, probably with some springs. And I'm hoping that I would be able to get the 10 by 10 by 1.5 cross section square section as well, that I need for the sides, which are going to be sort of like here. You can see the cutouts. So obviously I can't use different sections because it's already designed for the 10 by 10, which actually you can see a small section of the 10 by 10 there. But I need like, I don't know, 12 meters of that or something like that. So that's going to be the next challenge, but I think that should be all for today. So thanks for watching, and hopefully see you in the next one.